As you can see, I've got my engine up here on the bench, and I was just about ready to start the installation of the MVT Digital Direct ignition system, and then I started thinking about the ignition timing and how I would check it. And I don't mean how I would set it up, because as you've already seen in a previous video, I did make a dial indicator holder so that I can set up the ignition, but I also want to check the timing with a timing light. So the simple way to do this, and I've shown you this in one of my TPR 86cc videos, is just to make a mark on the flywheel, or the rotor in this case, which I could actually use that one if I wanted to, and set up a timing pointer to point to that mark when it corresponds to 0 degrees top dead center. So I'd set this up, I'd find top dead center, and then I'd make a timing pointer, usually just using a piece of wire, that would point at that, so I would know that when this mark was aligned with my timing pointer, that was 0 degrees top dead center. And then I use an adjustable timing light, and I can dial in the timing light so that it will tell me exactly where my timing actually is. So say if my timing was at 20 degrees, then these two marks wouldn't line up, it would be somewhere off. And I can dial in my timing light until those two marks align, and then whatever reading is on my timing light, so if my timing light says, say, 20 degrees and these are aligned, then I know that's where my timing is. But what I found when I was messing around with the timing the last time was that the further I got advanced on my timing light, the more jitter or jump I got when I was trying to look at it. So what I'd like to see when I'm looking at my timing light is that when these marks are aligned, it looks like they're just pretty steadily aligned. The light's flashing at the right rate, and it looks like these things are steadily aligned. But what happens is when I dial in a lot of timing in there, say the 20 degrees, and I get these lined up with each other, then I start seeing this bouncing around when I'm looking at it, and I can't tell exactly where my timing is. But I found that if I put a 20-degree mark on the flywheel, and then I just use my timing light set at 0 degrees, then I get a lot less jitter or bounce or whatever you call it. It's a much steadier signal, and I can tell more accurately where my timing is. So for that reason, I want to set something up so that I'll be able to see exactly where my timing is without having to use the adjustability of my timing light. It could be that my timing light has an issue, but from speaking with other people, for example, Peto Bread, who has his own YouTube channel and posts on my forum, he was talking about the delay and issues with his timing light as well, his adjustable timing light. So I think it's a pretty common issue, perhaps with a circuitry that they use or something, but I think it would be a better bet all around. If I could just make something here, I'll use the flywheel for the mark, but if I could use something here that surrounds the flywheel so I can easily see exactly where my timing is set without having to dial in advance on my timing light. The first thing I want to do is figure out roughly what the size needs to be of the plate that's going to surround this rotor. So I've got to start by measuring roughly what the diameter of the rotor is, and that looks like about 85 millimeters. So I know my inside diameter needs to be that plus a little bit of space for clearance. I've got my 103cc engine sitting up here on the workbench, so I've put the stator plate in place on there, and I can see that essentially as long as I stick with roughly the outside diameter of this mounting plate, I should actually be able to go a little bit larger, then I should be okay for clearance inside of these cases. And that's roughly 118 millimeters. What I think I'll do is try to make a plate with an 89 millimeter inside diameter. This is 85, so that would give me about 2 millimeters all the way around, assuming I'm lucky enough that it's pretty well centered. So that'll keep it nice and tight as far as making it easy to read the markings, how close they are to the rotor itself, and it should give me a little bit of a safety margin so that I don't have to worry about this running into the plate. For the outside diameter of the plate that I'm going to make, I'm basically going to use the diameter of this, but I'll add 4 millimeters, so this was 118. I'm going to try to make something that's 122 millimeters, and that should give me a nice wide area to put timing marks on and still be capable of fitting inside of the cases. I just took a look around the garage because I didn't want to have to go out and buy anything for this if possible. I was hoping to find some aluminum that was kind of thick, but all I've got is really flashing. What I did have is this disc of, I think it was 6-inch diameter, 60,000th thickness steel. So that'll work just fine for what I'm doing. I won't have to cut a whole lot of it away. and I won't even have to cut it down to fit in my lathe to make the first cuts. Doesn't look like I've done a brilliant job of centering that. Luckily, it won't matter. Looks like I just barely missed my outside diameter. This came out to 121.5 instead of 122, which really doesn't make any difference. Probably would have been pretty close, but made a really nasty cut there and I had to clean it up. And when I looked at it, I found that my little homemade cutter here, it chipped a corner off of it. Not sure if you'll be able to see it, but there's a corner chipped off right there. So I'm gonna have to regrind this. That hasn't gone as planned. So I started cutting and it didn't seem like it wanted to cut unless it was at a higher rate of speed. And then when I got it up to speed where I thought it was really cutting, it looked like actually what was happening was it was melting away the bit here. I'm in the process of switching the lathe around now because I don't know exactly what's going on, but instead of cutting into the workpiece, this is grinding away my cutting bit. So I'll put an angle in the end of it, and then I start cutting, it'll cut just a little bit, and then doesn't want to cut anymore. If I try to speed it up, basically it just turns red and I see that it's actually taking away my cutter instead of taking away any material from this. Tried regrinding it multiple times. I don't know why exactly it worked the first time and it won't now, what I've done here, but I don't know if it could be something to do with tempering or whatever, but at this point I'm just gonna switch it around. I've got a cutter, cut-off tool, parting tool, and I'm gonna mount it this way and hope I can just finish this cut because it's pretty far in there. But I've ground away most of my tool here, so I'm just going to see if this works. Certainly wasn't pretty there at the end, but I've got there, sort of. Now it has left a ring around the inside. It didn't cut it very well, so I'm gonna have to clean that up off of the lathe. So next I need to drill holes in this that correspond with the stator mounting holes, because I'm hoping to make some spacers up later so that this can sit elevated above the plate in the right spot to be where I need it for the rotor. I've got this kind of mocked up now, basically just because I wanted a quick way to figure out roughly how much spacing I need here. I've got 27.35 there, 27.56 there, so say 27.5, and then I'll add the thickness I've got above it here. Another 5 millimeters. So I want about 32.5 millimeter spacers, and that should be sufficient. I got lucky and I have some tubing around, so I don't have to drill through anything, but I am going to have to cut down the OD of it to make spacers because this is really tight up against the stator here. Now I've got two spacers. I ended up cutting them 35 millimeters in length instead of 32.5 like I initially said, because I figured the rotor will sit out a little more. Not that it's imperative or critical that this sits exactly level with it or anything, but it might make it easier to read. I didn't actually cut them down small enough to fit in here because I figured instead of removing so much material from the whole thing, I'm just going to grind down one of the inside edges on each of them, and that way they'll fit up and clear this area. You can see how far I had to cut that down just to get clearance because the stator sticks out so far past the plate down there, but they look like they should work now. So let's see if I can mount this up just for a test fit. Pretty close to where I was hoping it would be. So now, the other thing I've been thinking about is I'd like to elongate these mounts so that I could rotate the timing wheel, or whatever you'd call it here, relative to the flywheel. That way it should be easy to set, hopefully it should be easy to set maybe this mark that's existing on the flywheel or rotor as top dead center. I've done grooves in multiple stator plates before, and normally I just freehand that. I'll make some marks on there and just go at it with a Fordham carbide cutter by hand. But I thought, since I have this set up on the lathe, what I can do is I've got a cutter here that very closely matches the diameter of the hole anyway, which I don't have. There we go. And if I put that in there, maybe I can sort of rotate this by hand and slowly cut grooves that should be pretty symmetrical. So now I'm able to rotate this, and that way, let's say I have a 0 here on this outer ring, and when my engine is a top dead center, they're aligned with this mark here and my zero's over here, then I can just rotate this over and line those up. And one other thing I just checked was the access to the bolts here. If you can see down in there, the bolts for the stator adjustment, that if you loosen those up, allow you to turn the stator and adjust the timing. I was thinking I may have to remove some material from the ring in these areas so I could get to it. But it looks like I actually don't have any trouble reaching right in there with a ring attached, even without removing anything, so that worked out better than I expected. Now I'm just doing a little bit of mock-up using the 103cc engine that I've got on my workbench. And my initial plan was to use this mark that comes on the rotor as the all-purpose mark, so I can use that when I'm setting up the ignition to MVT standards as well as when I'm doing the timing. But they say that you should use the line, there's two lines here on the stator, and they say that you should use the line that corresponds with the arrow that shows the correct rotation of your engine. So I should use this line because my flywheel will rotate this way, and that would put me really close to my marks here. If I've got a timing mark here, if I say I use this as 0 somewhere around here, I don't have a whole lot of room to put timing marks on there. So I may end up having to mark the stator or the rotor a second time somewhere. It's not really a big deal because I'd really rather have my timing marks either maybe center them out here or center them over here. This would probably be the easiest one for me to see most of the time. So I'm thinking I'll probably try to set some timing marks up on here around here, and I'll just have to mark my rotor accordingly when I get there. My next job is to actually get some timing numbers on here, some lines that I can use as timing marks. And what I've done is on my site, on the forum, I've got a printable section, and there's a PDF of a degree wheel. This is a 2-stroke degree wheel that I made up. So I've printed that out at 101% because this was initially meant to fit on a CD or DVD, so you could easily make a degree wheel out of something. But this is just slightly larger, so I printed it at 101%, and that is actually a really, really good match for the size of this disc that I've made. So what could be done, the easiest way, would really be to print this out on sticker paper, line it up, and just stick this on there. Of course, cut the inside out. But I would like to have some etched or engraved or some actual physical marks on this thing instead of relying on paper. Maybe if I could print on vinyl or something, it would be different, but right now all I've got around is paper. And that's not going to hold up for really long if I'm lucky enough that this thing works out well enough that I want it for long. Anyway, so what I'm going to do is just use some school glue here, the glue stick, and stick the degree wheel, printed degree wheel, to the disc. I'll give it some time to set up, that way hopefully it won't move all around, and then I'm going to try to etch or carve right through the lines on here. That way I can hopefully pretty accurately make some timing marks. And the reason that I'm going with a glue stick, my logic here is, even though I have sticker paper, with a sticker paper, when I put this down into place, it's basically going to be stuck there. It's hard to reposition it. Whereas with a glue stick, I should be able to put some glue on here and then move it around so I can get everything lined up exactly as I need it. Now I'm just going to put a little bit of weight on there, and then I'll have to give that some time to cure. While waiting for the glue to set up, I was trying to figure out how I was actually going to get marks onto the steel plate. So I had a few ideas. The first was to try and engrave it using this diamond bit here in my Fordham rotary tool. Second was to kind of scratch it in or dig it in with this. And then last was just to use a utility knife with a razor in there. And all of those I would guide with just a piece of steel. I don't want to use my steel rule straight edge because I don't want to mess that up, but I figured I could guide them with a piece of steel. So I had the scrap steel from what I started as, the steel that I started with to make this plate. So I thought I'd practice with each of them and just see what worked. Let me see if I can get you a shot here. So this was me trying to engrave it, and I'm missing the marks a little bit, and I'm sure with some practice I could hit the marks, but misses the marks a little bit. It's a little tougher to do for me. This is from scratching it in with this, and those I could hit the marks right on. And then this is from using the utility knife or razor, and that one again I could hit the marks right on first try, no problem. So either one of these works as far as hitting the marks. The razor seems to be the easiest to me, and also the easiest one for me to see. So I think I'm going to stick with the utility knife when it comes time to actually put marks in the plate that I'm working on. I think that glue is only supposed to take something like 5 minutes to cure, but I gave it about, I think, 30 to 45 minutes just to be totally safe. And I also made a line all the way around the outside edge here, near the outside edge, because when I am carving in my timing marks, I'd like to leave some room between the outside edge and the end of any marks that I make, so perhaps somehow I can label those. And I think I'm just going to go ahead and cut out the center of this. I think it might just make it a little easier for me. I cut grooves for about 130 degree range, which is way more than I need. I did longer marks on each 10 degree increment and then short marks on 5 degree increments. I didn't try to get any tighter than that because I think that's kind of pushing what I'm capable of. So now I just got to see if I can get this paper unglued from there and cleaned up. Now the main thing that I'd like would be to put some actual numbers over some of the graduations. Maybe I can get numbers somehow over the 10 degree markings here. And I think that would kind of finish it up. The only other thing then I would really need would be a mark on the flywheel, which I can't do, or the rotor, which I can't do until after my ignition is installed on the engine. I just couldn't resist picking up a cheap stamping kit for about $14 to $15. They're 4mm letters and numbers. Mostly because I've got this far and I just kind of wanted to turn this timing indicator into more of a finished product. So I've never stamped before, but we'll see how this goes. I just finished up the stamping. Might have to put you a picture up here. I'm not sure how well this is turning out with the glare, but I stamped all of the 10 degree increments and then just the 2 5 degree increments nearest top dead center there, just so it's clear what the smaller graduations are. Also put B TDC over here and A TDC over here, so it's clear that this is before top dead center and after top dead center. So if top dead center is the 0 here, the further you are away from it in this direction, the more ignition advanced, the further it's happening before top dead center. And the further you go this way would be the more ignition retard, the further it's happening away or after top dead center. And of course I had to stamp 49cc scoot on here, which brings me to one thing, just in case you guys are actually interested in these. Again, these were like cheap 15 bucks on Amazon. They're 4mm tall stamps. With these cheap stamps, it looks like, granted I'm not a stamping professional, this is the first time I've ever done it, but I put masking tape down here to try and align my 49cc scoot, and the T, for whatever reason, is lower than all the others when I try to align it the same way. And that happened to me as well when I did the stampings up here, so I don't think it's just me the one time aligning it wrong. And also the 4s are not very good in this. It's a smaller number than all the others, and they don't necessarily align the way the others do, and that's every time that I tried to stamp a 4, the same thing happened. So I think probably you get what you pay for with these cheap stamping kits, although for 15 bucks, and this makes this look like more of a finished product, I'm not terribly displeased with it. Once I get there on the 86cc project, I'll show you how I set up the whole ignition system, as well as show you this in use and being set up again, I'm sure. But I just wanted you to be able to see the finished product in this video. And I know that this probably isn't of great interest to some people, and you can see that I certainly won't be doing any machine shop how-to videos real soon, because I'm not the greatest with a lathe. I'm still learning a lot on that. But I thought it was kind of a neat little project to get into, and hopefully you guys have enjoyed it as well. So with that said, thanks for watching. If you enjoy the video, please give it a thumbs up. Share it with anybody you think might be interested. And make sure you subscribe and check out the rest of this series and my other videos if you're not already subscribed. So thanks again.